Hey, geometry students! In this lesson, we are going to be talking about vectors. Now, this could be a really complicated lesson. Vectors is one of my least favorite things to teach to students who haven't learned about vectors before because they're really hard to grasp. But I think our textbook does a good job with this lesson because it's just an introduction to vectors and they don't get into anything really difficult, but they do show you some of the key features of vectors in a very accessible way. So I'm actually excited about this lesson. I think this one's not going to be too difficult, and it helps you understand something that's going to be a lot harder as you get more and more into it. I will tell you this: when you take physics, you will be dealing with vectors an awful lot in ways that are not as easy as we're going to be dealing with them here, but this helps set the stage for it. All right, what in the world is a vector? Well, a vector actually looks like a geometric figure, but it's not really just a geometric figure, okay? It's a quantity that has both a magnitude and a direction. Has both a magnitude and a direction. The direction of a vector is the orientation measured by the angle it makes from the horizontal. Now, here's an interesting thing. What does horizontal mean? It means that something goes like across a space. But you get to decide what across a space means. So you get to decide what the horizontal looks like, and then all of the vectors get measured from whatever you define as a horizontal. Now, if you don't understand what I just said there, you don't have to worry a whole lot about it. Just know that the direction of a vector is measured from a horizontal line, and you pick what the horizontal line is. The initial point of a vector is just the starting point, and then the terminal point of a vector is the end point. We're going to be using those terms as we talk about vectors. Vectors always start at a certain point, they end at a different point, and from the first point, they go in a certain direction. Hey, that means something really important about vectors. Vectors are like rays, like we learned about earlier this year. They have a specific direction, like rays had a direction. So you can't just interchange the starting point and the ending point of a vector because it has a specific starting point and a specific ending point. It's not just a line segment, it actually has a specific direction. At this point, why don't we take a look at what a vector looks like? This here is an example of a vector. Notice that we have a starting point A, an ending point B, and then my vector goes from A to B. The notation for a vector looks like this. If I name my vector, I'm going to call it X, but I'm going to put a little half arrow above it. Okay, so this is vector X. That's how you read that. And then we're going to learn what this little notation over here means in just a second. But can you pick out what 2 and 5 might refer to on this vector? Notice it goes from A to B, but as it goes from A to B, it goes over a certain amount and up a certain amount. So this 2, 5 almost looks like a coordinate pair, but notice it's not in the same parentheses that we put a coordinate pair. This one's in angle brackets. All right, let's keep going. The magnitude of a vector is just the length. Okay, magnitude is size, and direction is the orientation. So a vector has magnitude and direction. It has a length and it has an angle to it. Okay, now here's where that angle bracket comes in. The component form of a vector describes a vector in the simplest possible way. That's one of my favorite things about this lesson. It is very focused on what's called the component form of a vector. So I could give you the actual length of this vector if I wanted to. It's going to be a decimal that we have to calculate and round off, or I could give it an exact form with a square root symbol in it. Oftentimes, the lengths of vectors are irrational numbers just because we have to use square roots to express them. Well, this particular vector could just be expressed. The simplest way is just to say how far over it goes. That's this first number in this notation, and how far up it goes. That's the component form of a vector, and it simply says how far over, how far up. If one of these values was negative, instead of going over to the right, it would mean you're going over to the left. And if the second value was negative, it would mean instead of going up, you're going down. Okay? So we could have a positive first number going to the right and a negative second number going down. Notice that we can express any vector in 360 degrees here just by saying how far over it goes and how far up it goes, or technically how far to the left and how far down. All right, then two more definitions. Opposite vectors are just defined as vectors that have the same magnitude, so they're the same length, but opposite directions. Um, Whenever I subtract one vector from another, I'm actually adding the opposite vector. And what I need to do is just turn that vector directly around when I add it. And then lastly, a resultant vector. There's a specific process by which vectors are added together when you're thinking about it graphically, like adding two vectors together on the coordinate plane. It's really easy, though, to think of adding vectors together in component form, which is why I'm so happy that this lesson focuses so much on component form, because you're going to find, I think, that that's really, really easy to do. All right, let's get started with some practice problems and get our hands dirty with vectors. All right, so first thing we need to do is name the vectors and identify the initial point of each one. Oh boy, let's see. I'm going to need to make sure I grab a symbol here. So I'm going to go to insert, and I'm going to insert a special character. And let's see if we can find the vector character that looks like that. And it's going to be this one, okay? Notice it gives it sort of a weird name. Now, what I need to do with this is every time I write a vector, I need to put that symbol over the top here because that's how I express a vector. And I'm going to be very careful in this lesson about doing that correctly. Okay, so I need to name the vectors. My vectors are going to be vectors x, vector, that's a lowercase x, a lowercase y, and a lowercase z. This is a z with the little vector symbol above it. And for each one of these, I need to make sure I put this little, I think I called it a harpoon. I need to make sure I put this above each one of these letters to make it correct vector notation. Okay, now I need to identify the starting point of each vector. For vector x, the starting point is A. The initial point for vector y is C. Notice it's the side that doesn't have the arrow. And the initial point for vector z is point F. Now, I'm not actually supposed to name and identify the initial points of these vectors, but it's easy to do that too. For these vectors, they would be vector A, vector B, vector C, making sure I write them with that symbol over the top. And then starting points would be V, W, and Y. Okay, but we'll deal with those vectors in just a little